Alright, welcome back. Thank you very much for coming for the AMC Upper Primary 2019 question 26 to question 30 go through. My name is Teacher Chi Yew from Ting Academy, and I'll be your host for the session over here. So without further ado, let us begin on question 26. Let us take a look at what is this question about. So Warren and Naida makes a list of numbers. They start with 0. Then Warren adds 20 and Naida subtracts 1. So they start with 0. Warren starts to add 20 and Naida subtracts 1. Then afterwards, Warren adds 19 and then Naida subtracts 2. Now we can kind of see a pattern that's currently going on over here. So it kind of goes something along like this. 0, 20, 19, 38, and then 36. Now this whole pattern is going to continue until Warren adds a 1 and Naida subtracts a 20, which ends back up to 0. What is the largest number in their list? So in this case over here, we notice something. So Warren starts to add 20, Naida starts to subtract 1. Now we are going to find the largest number in this list over here. So maybe it will make sense if we try to list out maybe another pair of terms and try to see a little pattern that is going on over here. Now, so let me write this over here. So we have 0, Warren adds a 20, Naida subtracts a 1, we'll get 19. And then afterwards, Warren adds 19, we'll get 38. And then Naida subtracts 2, we'll get 36. Then afterwards, Warren will add a 18, right, which will obtain 54. And then Naida will subtract 3, which will get 51, and so on and so forth until it goes back down to 0. What we are looking for is the largest number in the list. Now, in order to take a look at the largest number, it can't make sense for us to pair up both numbers that are involved in the operation at the same time in order to see the net effect. What do I mean by that? Now, remember, Warren will always start to add a particular number first, followed by a subtraction by Naida. So we can consider them together and we'll try to view them. What is the effect after Warren added his particular number and Naida has subtracted away the number? So in this case over here, we notice that we have 3 pairs of numbers. We'll look at the second term. Right, we'll look at the second term because that will be the end of the operation. So after Warren has added his number and then Naida has subtracted a number, we'll be focusing on the second term of the pairs over here, because that will give us the most information on what is going on. Now, we notice that from 0 to 19 itself is a plus 19. And then afterwards, we notice that from 19 all the way to 36 is actually a plus 17. Moving on, we notice from 36 to 51 is actually a plus 15. Right? Hey, so the net effect starts off by adding 19, then moves on to 17, moves on to 15. We can kind of see a pattern that's going on over here. So in this case over here, we notice that you continue on all the way in this fashion. So we have plus 13, plus 11, plus 9, all the way to plus 1. Right, would that be the end? Now we notice that this wouldn't give us the largest number because this one is going to be another pair, right, for plus 1. What is happening in plus 1? At plus 1, we'll be expecting Warren to add a 11, Naida herself will subtract 10. But remember, after Warren adds 11, Naida subtracts a 10, Warren will begin again, and you start to add another number. And the next number itself is going to be a 10, because after Warren adds 11, he'll add 10 next. So this would be the largest number. And of course, in this case over here, we will not consider the other numbers because the net effect will be negative. In this case over here, we notice that after Warren will add 9 next, and then neither is expected. Warren adds a 10 next, and then neither is expected to subtract a 11, which gives a net of -1. So that's why we do not consider the other numbers now. So in this case over here, it looks really straightforward. We have 19 plus 17 plus 15 plus 13 plus 11 all the way to 1, and then we have a 10, and then we add a 10. Now you remember sum of odd numbers. The sum of odd numbers, essentially we have 10 terms over here. It's just a square, the number of terms squared. In this case, we have 10 terms over here. 1, 3, 5, 7, 9, all the way to 19. So it's just going to be 10 squared, and then plus the 10. And this one will end up to be 100 plus 10, which will give us a final answer of 110. Alright, so this one really requires a little bit more critical and logical thinking on how do we view patterns. And when we view patterns with multiple players, we will always look out for the net effect when we are analyzing the outcomes or trying to look out for the largest or the smallest values. Alright, without further ado, let's move on to question 27. So let's take a look at what question 27 is talking about. So different numbers can be made using the digits 1, 5, 6, 8 and a decimal point. How many possibilities are there if each digit must be used exactly once and the decimal point must be between the two digits? Well, so this one looks like a permutation and combination question. So what we can do is we can consider starting by arranging the digits. And the second step we can consider is to insert the decimal point. That would be our idea when we try to attempt this question. Now in this case over here, let's take a look. How many ways are there to arrange the 4 digits over here with 1, 5, 6, and 8? So in this case over here, it will be much more simpler if we write out 4 lines over here to indicate the slots for the numbers. Now let's take a look at this idea of multiplication principle. Now in the first slot on the most left side, how many ways can we put the 4 numbers inside? Well, we have not chosen anything, right? So in this case over here, there are 4 ways. Because anyway, in 1, be it 1, 5, 6, or 8, any of these 4 numbers can belong to a first slot. So great, we are done with the first slot. What about the second slot? Well, 1 number has been chosen. We are left with 3 numbers. So in this case over here, there are only 3 choices left for us for the second slot. In the same fashion, for the third slot, there are only 2 choices. And then for the last slot, there's only 1 choice. Now, in this case over here, we'll multiply all these numbers up. And we will obtain the number of ways to arrange the digits. And this is also known as the factorial function. So 4 factorial is equal to 4 times 3 times 2 times 1. Now, what's next? In this case over here, we are done with the first step, which is to arrange the digits. Now our second step is to insert the decimal point. But be very careful. We notice there's a restriction over here. The decimal point must lie between the 2 digits. Now, where will be appropriate spots for the decimal place in this case? It can be here, it can be here, it can also be here. So how many ways are there in this case for me to put 1 decimal point in between the numbers? Well, there are just 3 ways, right? Alright, so in this case, decimal point 3 ways. So what would be the total number of ways in this case? Well, we are going to take the 4 factorial multiplied by 3. And this one will give us a final answer of 72. Alright, so I hope everyone is able to understand how do we actually figure out how many combinations are there when we are trying to arrange particular number of digits over here, and then how do we manage restrictions and conditions that are involved in this kind of questions. Alright, so without further ado, let us move on to question 28. Now in this case over here, John is 1 year older than his wife, Mary. Right? They have 3 children whose ages are 2 years apart. So the 3 children ages are 2 years apart from each of them. Now, the product of John and Mary's ages is less than 2019. And the product of the 3 children's ages is also less than 2019. Next year, both these products will be greater than 2020. So in this year, what is the sum of all 5 ages? Now, this question is a little bit more challenging, but fortunately, we are allowed to use the calculator over here. So we are going to try to do our best and use our calculator. Now, in this case over here, let's take a look. John is 1 year older than his wife Mary. We will focus on the parents first. So John is 1 year older than his wife Mary, and the product of John and Mary's age is less than 2019. So remember from our perfect square and perfect cubes lessons, right? We are going to apply our square root function in this case to try and estimate what will be the appropriate age for John and what will be the appropriate age for his wife Mary. So in this case over here, let's take a look at square root of 2019. So John and Mary. So in this case, we can simply use our calculator, put it inside, put this value inside, take square root of 2019, and we are going to get roughly 44.9. So in this case over here, we can expect their ages to be somewhere between around that area. Now in this case over here, we can estimate that Mary's age will be roughly 44, and John's age will be roughly 45. But before we continue, we need to always check and see whether it makes sense and whether it satisfies the conditions. So let's take a look. 44 times 45. It's going to be 1980. This itself is less than 2019. So our first condition is satisfied. But what about 1 year later? After 1 year, what will be the age of John and what will be the age of Mary? Now in this case over here, it's going to be pretty straightforward, right? Mary herself is going to be age of 45. And John will have the age of 46. So what is going to be their product? Their product is just going to be 45 times 46, which will add up to 2070, which is greater than 2020. So that's good. We satisfied both conditions. So in the same fashion, let us move on for the children as well. So in this case over here, we are going to, because we have 3 children, we are going to let n represent the age of the middle child. Simplify things. And then we keep in mind that we know that the cube root of 2019, using our calculator, would yield roughly 12.6. So in this case over here, the middle age over here, we can roughly estimate it as n equal to roughly 12 as the age. So now we have to check whether it works. Since their ages are 2 years apart, let us take a look at the first condition first. So in this case, the youngest child will have an age of 10, the middle child 12, the oldest child will be 14. So 10 times 12 times 14 is going to give us 1,680, right? Which is lesser than 2020. So that's good. Now let's move on to the next condition. 1 year later, their ages are going to increase by 1. It's going to be 11 times 13 times 15, which is going to be 2145, which is larger than 2020. And therefore, we can conclude that these are the actual ages of the parents as well as the children. But is that all? No, right? So in this case over here, we have to find the sum of all their 5 ages. So the sum is going to be 44 plus 45 plus 10 plus 12 plus 14, which is equal to 125. Alright, so I hope this one will give you a deeper use and insight on how do we tackle this kind of questions by doing appropriate estimation as well as using our calculator, since calculators are allowed in the AMC paper. Right, so without further ado, let me move on to the next question, which is question 29. Now, let's take a look at what question 29 is about. In this case over here, a 7-digit number is in the form 20 AMC 19 with all digits different. It is divisible by 9. What is the value of A plus M plus C? So that's our question. So in this case, we give you a number with 3 different letters represent different numbers. And this number itself is divisible by 9. So this one, when we have divisibility by 9, when something is divisible by 9, it's going to be like something along this line. The sum of digits is divisible by 9. So all we have to do is look at the sum in this case. But remember, all the digits are different. So it can't make sense for us to actually give a check on what other numbers, what numbers remain after removing 0, 1, 2, and 9. So let's take a look. So in this case, we have all the numbers over here. Right, we're going to slash off a few numbers. Slash off 0, slash off 1, 2, and 9. So we are actually left with these 6 numbers: 3, 4, 5, 6, 7, 8. And we are going to check out our divisibility by 9. So in this case over here, we are going to take the sum, right, in hopes that we can get a multiple of 9, and hence it will be divisible by 9. So we have 2 plus 0 plus A plus M plus C plus 1 plus 9. Right, this one is going to be A plus M plus C plus 12. Right. Now, in this case over here, we require this to be a multiple of 9. So the first thing that immediately comes in the first thing that immediately comes into our mind is, hey, what about next number 18, right? So is 18 possible? So if it's 18, this one must sum up to 6. Is 6 possible? Now we have to go and look back at our digits over here to see whether any 3 digits over here can form a 6. Well, in this case over here, we notice that it is impossible for us to form a 6 using 3 digits from 3 to 8. Right, because the minimum starts from 3 and we are continuously adding. So 3 minimum itself is probably 3 plus 4 plus 5, right, which is much greater than 6. So it's impossible. Now, so in this case over here, what do we have to do? We have to go another round, aka add another 9 in this case. So 6 plus 9 is going to be 15. What about 15? Is it possible for us to form a 15 over here using 3 digits? Yes, in this case, because the numbers 4, 5, and 6 add up to 15. And hence, we can immediately conclude that A plus M plus C must be equal to 15. Now, just to do a quick check, notice that 15 plus 12 is equal to 27 as a multiple of 9. And hence, this number itself is divisible by 9. Alright, so I hope through this question over here, you guys can understand a little bit more about the divisibility tests. The common ones will include things like 3, 9, 2, 4, and 8. Alright, without further ado, let me move on to the last question for this video. Now, I have 5 children and want to place them in a line for a photograph. However, Hugh refuses to stand anywhere in between Louis and Richard. How many ways are there to place the children in line and still keep Hugh happy? Now, so in this case over here, it's very important for us to keep a lookout for the phrasing of the question. Now, Hugh refuses to stand anywhere in between Louis and Richard would really just mean that be it anywhere. So suppose Hugh represents H, and we have Louis representing L, and R representing Richard. Now, basically, Hugh cannot stand anywhere in between Louis and Richard. So things along this line will not work. Right? So Hugh cannot stand in between Louis and Richard. But in the same fashion, someone else can be in between Hugh and Richard. And Hugh and Richard Hugh will not stand in between Louis, because Hugh is still technically in between Louis and Richard, and hence this one would not be appropriate combination as well. So in this case over here, how do we tackle this question? Well, we can actually consider the insertion method again, just like what I have mentioned to you in our decimal component question 27. We can try this out as well, but we are going to manage the restrictions much more closely. Now, so let's take a look at where Hugh will have to stand and where Louis and Richard will have to stand. So, taking a look at this, Louis and Richard must stand in this fashion. Louis may be on the left, Richard must stand on the right. But hey, it is also definitely possible that Richard stands on the right and Louis stands on the left. And Richard stands on the left and Louis stands on the right. So in this case over here, there are actually two possible combinations. Now, how about Hugh? If Louis and Richard stands in this fashion, where can Hugh stand at? Now, in this case over here, he can stand on the extreme left-hand side, or he can stand on the extreme right-hand side. These are two possible spots for him. So there are two for Hugh as well. Now, so imagine, now we can start to imagine that maybe Hugh has decided to stand here. Where can the other kids stand at? We still have two more kids over here. Well, the first kid will actually have 4 places to stand at. Right, so the first kid, maybe I'll denote it as A. We have 4 places to stand at. So now maybe he has chosen a place. Maybe he's happy with being in between Louis and Richard. What about the second kid? Well, the second kid, we notice now we have 5 gaps over here. The second kid, I will label it as B. There are 5 ways for B. So, following our logic from question 27, we can actually multiply all these numbers together, get our final answer. So in this case, over here, the total number of ways would simply be 2 times 2 times 4 times 5. Alright, in this case over here, you add up to the final answer of 80. Alright, so we've come to the end of our video solutions go through for AMC Upper Primary Division 2019 paper. Alright, so if you guys have any questions with regards to questions 1 to 25 for this paper, you can feel free to WhatsApp me and I will get back to you as soon as possible. Alright, so with that, do keep a lookout for our next set of paper, and I will see you again next time.